Welcome to Disruption Dialogues Podcast Season 2. Listen to the influential leaders and trailblazers from around the world as they share invaluable insights to navigating the fifth industrial revolution.
Hello and welcome to another episode of Disruption Dialogues Season 2. I'm Robert Outram, Vice President for the Chemicals, Materials and Food Group at Markets and Markets. Today I'm in conversation with Sophie Borgne, Water Segment President at Schneider Electric. Sophie Borgne, a seasoned professional with over 20 years experience at Schneider Electric, excels in digitalization across process, power and energy management solutions globally. She's also a dedicated advocate for STEM and a proud recipient of the Hanover Mess Engineering Power Woman 2020 Award. So thank you for being with us today, Sophie.
Thanks for having me, Robert. Hi.
Brilliant. Okay, so into the questions then. Obviously, Schneider Electric, huge company. Why has Schneider decided to focus on water as an industry?
Well, we are a huge company. We have been very present in the industry overall for decades, if not century. And water industry is an industry consuming a lot of electricity. And with our roots that we can hear in our name, Schneider Electric, we have been serving the water industry with a solution to optimize their power supply for the last decade. So the water industry accounts for 4% of the overall electricity consumption around the world. So that's one reason. Second, water industry is a process that can be automated and optimized. And this is a second axis of what Schneider does. We are pretty strong in process automation, and we have been providing the water industry for decades as well on how to automate their process to treat fresh water into drinking water, to treat wastewater into fresh water, and to manage overall water networks.
Okay, brilliant. Yeah, I know there's been a big push, not just in the water industry, but throughout the chemical industry as a whole, materials industry to automate and bring in some of these digitalization processes. So yeah, it makes sense to have that in the water industry as well. As I'm a keen swimmer, particularly open water swimming as well. And I notice whenever I travel around, there's, these rivers like the Thames in London and the Seine in Paris, very different to other regions like Zurich, where I went to recently, that had beautiful, clean rivers. And I was just wondering what regions or market areas will we see the biggest investment in water in the future?
Well, the good news is there are investments all around the world. I fully agree with you on your concern for the big rivers in our big European cities. You mentioned the Seine. I'm very happy I could secure a few tickets for the triathlon for the 2024 Olympics that will be in Paris, where the swimming part will happen in the river right down Paris city center. So I'm very excited about that. It is posing huge challenges to get the water quality to the appropriate level. But with the plan that is in progress to invest in infrastructure, in particular to store stormwater overflow and in infrastructure to treat the water upstream of Paris, I'm pretty confident that I will see a competition in the Seine right midtown Paris. And well, you mentioned the Thames as well. I happened to be in London last week, where I met with a representative of the Environmental Agency, and she was sharing the progress on the water quality in the water rivers in UK, and it was pretty impressive to see how the quality of the natural bodies of water have improved. I think it's valid across Europe. Now, the starting point is different for different points around the globe. The willingness to invest is shared, and I do see investments in each and every country into water infrastructure.
Okay, that's good to hear. Well, I'm a triathlete myself, and I'm appalled at the state of the Thames. I'm based in the UK, so really good to hear that they're actually doing something about it, and that there is investment in water quality. And you mentioned seems to be the storms. When particularly with this climate change, we seem to be having huge downpours, and that water's obviously got to go somewhere and spill over. And particularly in the UK, you're allowed to release. So I think they have a certain number of allowances per year for storm conditions where they're allowed to release untreated water into the rivers. So hearing that they are investing in that infrastructure is encouraging, thankfully.
Yeah, well, you're spot on when you talk about climate change. We know that's happening, but what is maybe a bit less known is that most of the impact of climate change will be felt through the water cycle. So the water industry needs very heavy investment to get prepared to those exceptional events. When you size an infrastructure, we used to size it for the average level of water. Now we have to size it for extreme volume of water pouring at the same time. And this is a big change of scale. Yeah.
Okay, well, I'm glad that's being recognized. Okay, we're going to go into some details in some of the later questions, but I'm just interested at the top level, Sophie, where you see the future of water treatment and water management.
Well, I will start by stating that there is a big burning platform on water management. There are estimates from the World Economic Forum stating that by 2030, which is tomorrow, the gap between the need in water and the availability of water is going to be 40%. So we will have 40% less water than we will need by tomorrow. So all those discussion it's good to discuss, but they need to drive action right now. So the future of water it needs to start now. And the only way we are going to figure it out is by thinking in systems. Of course, we have to optimize individual water treatment plants, individual municipalities, network, but water is flowing and it doesn't need a visa to cross border. So the water cycle is running in a very wide system, and we need to think globally. We need to think about urban water, which is the one that, you get when you open your tap or flush your toilets. We need to think about industrial water, and we need to think about agricultural water for irrigation. And we need to think about it as a full system. It's not independent, it's not autonomous. There are a lot of interdependencies. So the systemic thinking around water for me is really the key to the future. Now, if I move a bit to technology, I think there is a very important starting point here as well. You can't fix what you don't see. You can optimize what you don't measure. So getting information on your water system is a cornerstone of optimizing it. So I do see the future with massive digitization investment to actually know what is happening. And it's only when you know what is happening that you can start to optimize. And here we have wonderful technology that are emerging, that are mature enough to be scaled if you just apply machine learning, a bit of AI to optimize the overall water network, we can make great things. But it starts by measuring.
Okay. That makes a lot of sense. I think it will come as a surprise to most people that water management is so emissions intensive. Things like The desalination plants is kind of obvious, takes a lot of electricity to produce desalinated water, but in general, the emissions from water treatment and water management, I think probably goes under the radar for most people. But I know you're at Schneider Electric are focusing on reducing emissions in this sector. Can you tell us a little bit about how you're doing that?
So first, you're absolutely right. The water industry overall accounts for up to 10% of the global greenhouse gas emission. So incredible. It's huge. And it's because as well, the mix of emission, it's not only carbon, it's methane, it's N2O, which are gas with a very, very high carbon footprints. And this comes a lot from wastewater treatment. When you treat this water, there are a lot of gas that gets emitted, and that can be optimized as well. That can be optimized by adapting some treatment process parameter, by optimizing your mix of which chemical products you are going to use to clean this wastewater, how you are going to play with all the different possibilities of using bacteria to digest the waste. There are a lot of both chemical and biological ways to treat water, and you can optimize that real time with the intent to reduce emission. If you look back, and I think this is not only for water, actually, it is across the industry. Optimization started by optimizing for efficiency. So optimizing your process to get the highest output for the lowest cost. In the water industry, that will mean optimizing your process to treat more cubic meter of water per minute and to decrease the cost of that. Then a few years back, the focus is still having efficiency in mind. There was more awareness on energy efficiency. And we've seen a lot of project and investment, and we made significant business in helping the industry to optimize their energy bill for the same amount of throughput, for the same industrial productivity. And this is nice because it has a direct impact on your costs, so on your profit and loss. The next chapter is to have a similar optimization, but to optimize the emissions on top of optimizing your P&L. And that's coming. That's going to be accelerated by regulations. And I hear a discussion in Europe and in some other countries as well to mandate the water industry to measure and then decrease its greenhouse gas emissions. So the technology to optimize is somehow the same, but the prompt you give it, you can program it to optimize for cost, you can program it to optimize for energy use, and you can program it to optimize for emission.
Okay, interesting. Now, you mentioned earlier that water is a finite resource, and that statistic I think you mentioned of a 40% gap between what we will need and what we have is slightly alarming, at least to me. How can we be more efficient and make the most of this water?
And you're right. It's been a big surprise for me. I've been in the industry overall for a long time, but in the water industry specifically for a bit of a short time. And it came as a shock to realize how scarce water was, because, well, when I look around, I kind of see water everywhere.
Exactly, yeah.
When first the water we use to drink in our industry, for irrigation, etc., is fresh water. fresh water only accounts for 3% of the overall water available on Earth. So that's already a much smaller chunk of water that is available for use. And this fresh water, this is where the pressure is. This is where the scarcity is going to come. There is a very first easy fix because there is another figure I'd like to put into perspective against the 40% gap, and that other figure is 30% water loss. That's in the water infrastructure of fresh water, water that has been purified and is then distributed in a water infrastructure, 30% get lost before it goes to the point of use, which is as well the point of billing. So there is double impact of waste of water and waste of revenue as well for the water utilities. And that's the loss is called leakage. So addressing leakages in our water networks is a mandatory first step. The reason we have leakage is, well, water infrastructure can be very old. If you think about it, in Europe, some of it goes all the way up to the Romans. So we have part of the water infrastructure that is 2,000 years old. And it's a great testimony to the engineers of the time that it's still existing. However, it needs a bit of maintenance sometimes. So maintaining the water network and really redoing the piping to minimize leakage is a must. What's challenging is where to start, because there are thousands and thousands of kilometers of water pipes. And of course, you cannot change everything at once. It will mean just huge construction work everywhere. So what is a good way to start is to have tools that are going to help you to locate the leakage. And to do that, you don't need to open trenches or to have a guy walking along all those 1,000 kilometers of pipes with a meter. Here, technology can help. And you can use an hydraulic model that is going to simulate the pressure in the water network, how it should be if it was not leaking. And you can compare that against the real-time data of the actual pressure in some key points of your network. When there is a gap, the analysis of this gap is going to determine where the leakage is coming from and how big is the leakage. So with that mapping of your network and where are the most critical leakage, then you can plan your workload, you can plan your construction work, and you can start maintaining the water network where it needs it most.
Okay, that's quite an interesting approach, modeling the pressures. I mean, for the chemical industry where I'm from, I see analogies with the oil industry, where they have these things called pigs, which are basically sensors that they send actually down the oil pipeline, and they scan the condition of the pipes as they move through the system, and then they retrieve the pig at the other end of the pipe, and they get a sort of radar or a kind of map of the pipeline, where it's corroded, where it needs replacing, etc. But this is quite interesting, doing that pressure modeling to find out where the main leaks are. Because you're right.
It's quite similar indeed. When you are with oil and with gas, you have a distribution network made of pipes, and it's exactly the same for water industry. And a lot of technology providers are the same one actually, and they excel at optimizing distribution pipeline network.
Okay, so you mentioned this the digital technologies, but what are the key innovations that you've seen in this, the circularity of the water? I think that's key with the fresh water, keeping that circularity. And, what technologies we've discussed the pigs and the pressure sensing, what technologies do you see winning through?
I see a lot of innovation going on in the water reuse field. Water reuse meaning how many times can you use the same amount of fresh water before it goes back to a body of salted water. And this is very true in what we call industrial water, which is 20% of fresh water that is used for the industry. Some industries are using a lot of water. Think about semiconductor, think about data center for cooling, think about mining, or even oil that for drilling. They do inject a lot of water. So in those industries, there are a lot of innovation going on to be able to treat the water locally and use it several times in the same process. So it may not appear as fancy as the digital twins that we use for the water network. However, the water reuse technology are pretty high-tech and will have a big impact as well on addressing the water supply gap.
Okay. Now, in the UK, we're surrounded by water here. It's February now. There's a lot of flooding. The rivers are bursting their banks. Seemingly, as you mentioned earlier, there's water everywhere, and yet, with the aging pipe network that we've discussed, and the horrendous mismanagement of water leading to water shortages. In fact, in the UK, even though we're swimming in water, it would seem now, it's quite common to have, particularly in the last few years, we've had quite hot summers. It's quite common to have hose pipe bans or the threat of a hose pipe ban. People talking about water shortages and droughts, and that's just in the UK. In other countries, Portugal, Spain, obviously incredibly hot there. They have a lot persistent droughts. Are there any solutions to this? What needs to happen with the management of water to make sure that there aren't these big gaps in terms of demand and supply in the future?
Yeah, and you're right. When there are maps available on the level of water stress in different countries, and I was very surprised to see countries from Northern Europe being tagged as rather or high, all things considered, high water stressed area. But it is happening, and there is more and more seasonality, and those extremes are impacted by climate change. They are augmented by climate change. And to be able to manage that, it's very important to have a very strong water stewardship on the overall network across the years. And it means building storage facilities. It means having real-time prioritization of the use of water, but along a full river basin. It's pretty obvious that if all the water is used upstream, there is none left for the users downstream of the river body, and it needs to be thought through. And it needs to be managed. And what we see is more and more entities or net group of industries, municipalities, governmental bodies coming together to think really in terms of river basin and optimizing, having a very strong water stewardship along the full river basin. It's challenging not for technological reason. It's challenging because the river basin cartography does not match somehow the decision mapping, which is the one by district, municipalities, regions, etc. So one river basin typically goes across different cities, different states that need to agree, and it's more difficult to establish one overall stewardship for this river basin. But it is happening in some places. And it's really the system thinking that is needed if we want to address all those overall issues.
Yeah, and you know, it's interesting because some of the, as you mentioned before, some of these river basins, they actually cross borders. So I mean, the Rhine River, I know the chemical companies, for instance, or the industrial companies in Germany, they're struggling with low water levels in the Rhine. That they'll typically move their shipments up and down. And of course, the Rhine doesn't start in Germany; it starts up in the Alps with melting glaciers. So it's a big problem. Just, you know, not just one country. The multiple countries need to get together to discuss how to manage that water.
Yeah, so there is a big project that has started, well, in US, but it's pretty visible in the media, so I think a lot of us will have seen it, around the Colorado River. The Colorado River level has been very low lately. I think we've all seen image of a Lake Powell that is so low that you're actually looking for the lake. And it is crossing several states, and it is serving a lot of people and industries. So there is a big project for all those industries to come together to agree on how to share these common goods that is fresh water.
Yeah. Now, you mentioned some of this scanning of pipe networks and mapping, which is fantastic, and digitalize, you know, water treatments. At least in the past, has been quite an old industry, you know, using filters and bacteria, and probably less so much on the digitalization side. How is digitalization really going to step up and play a part in water management going forwards?
Well, let me take the example of desalination. That is an area that is booming right now. Because fresh water is so scarce that in some areas, the only available choice somehow is to turn salted water into fresh water. So desalination technology is pretty advanced. You have membranes for reverse osmosis that allow to change salted water into fresh water. The challenge is that it is very, well, it does consume a lot of energy. And through digitalization, we are running algorithm, and it's data science. So it's gathering a lot of data. It's running machine learning algorithm, AI, to track down, to really reduce significantly the energy consumption of desalination plants. And we've seen significant progress in the last years. There is still some potential, a lot of innovation going on there to really optimize the technology for minimum energy use. But the reverse osmosis is a pretty advanced technology that could unlock, if you think about countries in the Middle East, where they have really few sources of fresh water per se. So having access to salted water as a source of fresh water is really a game changer for them. And a lot of investments are going on there. If we collectively as an industry can really come up with technology that will cost per amount of water the same than the traditional water treatments, this will be a game changer in a lot of countries.
All right. You mentioned AI there. I mean, AI is a buzzword in a lot of industries at the moment, and I must admit I'm slightly skeptical of what value some of these sort of technologies can bring. You know, What's your opinion on AI? Is there anywhere that it can, genuinely make an impact or a difference for the future of water?
Yeah, so they do, and there is a lot of potential for AI to make even a bigger difference. And there is a lot of benefits from AI in each step. It starts at designing phase. When the need for new water infrastructure is huge. So there are a lot of new water treatment plant, water networks that need to be designed, and there generative AI can take a big part of the load in terms of design. So combining generating AI with engineering software can actually significantly reduce the cycle needed to design new water treatment plants, thus to implement new water treatment plants. So that's for the design engineering phase. Then in operation, so machine learning can help to optimize the production parameter to get, back to what we discussed earlier, to get the best output or the lowest energy bill or the lowest emission, and ideally a combination all of the above. AI can help as well the challenge that the water industry is facing with its workforce. And when you are operating a water network are big geographically. So water operators are working typically not in an office. And when they are on the field and they need information on how the plant is operating, etc., AI can provide can be a great assistant. So it can be a co-pilot for the water operators. So the opportunity in terms of co-piloting water plants with AI assisting an operator are big as well. And lastly, when it comes to maintenance, AI can do a lot in terms of predictive maintenance, and it's way more efficient to do maintenance work before it comes to a failure. This potential is huge as well.
Yeah. Okay, interesting. So it seems like the biggest benefit is sort of saving money, which is a key thing, and it sort of leads on to my last questions. I mean, government authorities, I'm, as you can probably tell, slightly frustrated with the UK government and local water authorities. There's leaks, and there just isn't the investment in the infrastructure needed to manage and treat water efficiently and properly. How do you see the role of private companies like Schneider Electric, interacting with these government authorities and these water companies to make sure water is, treated properly and efficiently?
Well, several aspects to answer that. Water is an industry where there is a lot of public-private partnership and probably opportunity for more. I do see a lot of governments and specifically environmental protection agencies very proactive to work on a new regulation to drive the water industry towards a better use of water. So that's working. Now the partnership is very important when it's come to innovation. So we need to continue to accelerate on the innovation. On the investment itself, I have to say that I was happy to say that to see a lot of the post-COVID stimulus packages that different governments put together, pointing a lot towards water infrastructure. That's very encouraging.
That's good.
Now it's a question of speed, because back to my opening statement, 2030 is very close. And the time between government discussion and the actual start of operation of a new water network is long. If we could only shorten this cycle from political decision to operational ignition, that would be really great.
Okay. Anything else, Sophie, you wanted to point out before we wrap up this podcast?
Yes, there is one point that we didn't discuss, and I think it's an important one, is cybersecurity. Okay. I don't want the digital story to be painted too bright somehow. There is a lot you can do with digital, and I discussed a lot about machine learning, AI, etc. Let's not forget that with that come vulnerability. So it is very important to understand the risk linked to cybersecurity and to mitigate them. There are solutions to mitigate them. It's not a deal breaker, but water infrastructure are critical infrastructure, and a lot of water utilities are actually being attacked by hackers. So I really want to call everyone in that industry to both embrace the potential of digital transformation, but be mindful and take the appropriate action as well to mitigate the cybersecurity threats.
Yeah, that's an incredibly interesting point for me. And again, coming from the chemical industry, I think it was just a year or two ago that the hackers managed to hack into just one company in the US that controlled the oil network and the pipelines, and basically brought the country to a standstill. And that's oil. You know, you can do without oil for a few days or a week or something, but water, you know, is much more critical. So yeah, I mean,
absolutely. And very sadly, you know, when I have speaking opportunity, this is a common opening statement. And whenever I Google for a new article on water utility being hacked, sadly enough, there is always one in the last few days. So it is happening very often. So there is really a need to upgrade not only the physical infrastructure, but the digital infrastructure as well.
Yeah. Okay, brilliant. Sophie, thank you so much for this discussion. It was really, really enlightening to talk to you. And thank you everyone for listening in. I was in conversation with Sophie Borgne, water segment president at Schneider Electric. Sophie, thank you very much for your participation. It was greatly appreciated. Thank you once more. Stay tuned for more interesting episodes on Disruption Dialogues.
Thanks for tuning in. If you want to know how you can navigate and thrive in this disruptive era, subscribe to Disruption Dialogues on your go-to podcast channels and stay tuned for more interesting episodes.